Hi. Today we're going to be starting to talk about the math that we're going to have to do in chemistry class. Yes, I know, math. But what we're going to be learning how to do is a simple process, okay? And I'm going to try and make it as easy as I possibly can for you guys. Now, this process is going to usually involve conversions. Matter of fact, that's all that this is all about, is unit conversions. And in chemistry, all of these conversions are usually going to be set up or presented as word problems. And with all word problems, it's important to be systematic in your approach. There's a certain method that you should always use. All right. First of all, you should always ask yourself, what is it that the question is asking? What specifically is it asking? Now, for doing these problems, I call this the end point or the ending point. Now, the end point is kind of like if you are trying to find directions how to get somewhere. Let's say you want to go to your friend's house and you use Google Maps in order to do it. The end point is basically the address of your friend. All right, you enter that in. All right, in a word problem, it is specifically the number and units that the question is asking for. All right. Where you're starting from, which I call the starting point, that's the information that the problem provides. Again, if you're using Google Maps, that's going to be your address or wherever it is that you're starting from. And usually in the conversions, it is a number and a unit. All right. And then the how do we get there part that Google Maps does for you, that's going to be a little bit more challenging. In chemistry, that's where the hard part is. That's where you have to figure out what equalities you need. Those are conversion factors. We'll talk about those in a minute. You'll set up a grid and then solve. All right. And then solve. And then finally, when you're all done, you want to take a look at your answer and see, hey, does this make sense? All right. If you're converting from, let's say, 42 inches, and the question is, well, how many miles is that? And your answer is like 1,000 miles. No way does that make sense. So go back and double check your work and make sure you set it up correctly. All right. Now, when converting units of measurement, we're going to always be using a process called unit analysis. Now, some books call it dimensional analysis. It's exactly the same thing. Basically, it's a process where you analyze the units to show you how to set up a problem. And it's going to teach you when to multiply, when to divide, and all that good stuff. All right. And this process is useful for any conversion. We will learn the process first by doing metric conversions. Then we will use the same process with chemistry-specific terms. Now, the first step when doing a unit conversion through unit analysis is that you need to determine the starting point and end point for a problem. Okay? Now, this is the number and units given in the problem. That's the starting point. Whereas the unknown number and units is the end point. This is what the question is asking for. So just, as an example, let's say you were looking at the number of, inches in a certain number of miles or kilometers. Let's put it that way. So let's say you have 13.4 kilometers, and the question is, how many inches is that? Well, you write out the number and unit of your starting point. Then you'd write out the number or the unknown number and unit of your end point. So number, unit, starting point, and then like a little arrow saying that we're trying to get to the unknown number and unit of the end point. Now, the second step is to write out the equalities, also known as the equivalence statements or equivalencies. Now, basically what these are your conversion factors written out where there's one value equal to another. Now, this is always going to be different depending on what type of problem you have. But they can be anywhere from like how many eggs are there in a dozen or how many days there are in a week. Some of them you know off the top. You know that there are 12 eggs in a dozen eggs or 7 days in 1 week. And you can see how you write them as an equality when you have an equal sign. All right. So you have 1 dozen eggs is equal to 12 eggs. That is your equality. Another equality is 7 days is equal or equivalent to 1 week. Notice how both values are equivalent to each other. All right. And keep in mind, you must always include numbers and units. This is so important. If you just put 1 is equal to 12, well, first of all, that's not true. And second of all, you're going to get extremely confused. So you want to make sure you write them out. Now, for metric conversions, you're going to be writing out your equalities as a 2-step process using the metric conversion chart. That's this guy right here, and you'll have access to this whenever you're trying to do any of these problems. All right. Now, it's a 2-step process because you have 2 sides of the chart. One side is where you have the equalities that get you from or to the non-metric or imperial units to the metric units. All right. The first column over here is all the non-metric units, and they're going to be equal to a certain number of metric units. And notice how on the top, it gives you the directions on how to use it. First, find the non-metric unit on the left side of the table and write down the entire equality. Include both the number and units. All right. So you always look there. So let's say in our example, we're going from kilometers to inches, right? Well, metric units always end in gram, meter, or liter. So between these two, which one is the metric? Well, since it's kilometers, kilometers, since that ends in meters, that's the metric unit. The one that doesn't have meters or liters or grams is the non-metric. So we look for the non-metric over here, and we look for inches, and we see it's right here. It says 1 inch is equal to 2.54 centimeters. So I write that down. I go 1 inch, number and unit, is equal to 2.54 centimeters. All right, and I write down the number unit equal to number unit, just like it shows on the left-hand side. All right, so you write down what is written on the chart. Again, for example, 1 inch is equal to 2.54 centimeters. Now note, at this point, the units in the equality might match those of the starting and end point. If that's the case, then you're done using this table. For example, let's say the problem, instead of going from kilometers to inches, was going from centimeters to inches. Just for, kicks and giggles. Let's say it was going from centimeters to inches. Well, if you notice, you have centimeters, centimeters, inches, inches. In this case, you only need one equality, and you're done with the problem. However, this particular problem was going from kilometers to inches, so we have to keep on going. Once you've established that you have the first side, once you use this first side of the table, you only use it once. That's it. All the other conversions or equalities are going to come from this other side. Now, the next step is use the right side of your metric conversion chart to look up all metric units with prefixes from both the problem and the first equality that you wrote in step 1. You're going to look them up by their prefixes from the column at the far right of the chart. So if you notice, so far we have 2 metric units. One of them is kilometers, and we also have centimeters. Again, it said you're going to look them up from the original problem and from the first equality that you just wrote down. And you're going to use the far right-hand side of the chart. Well, in this case, we're going to first of all look up K for kilometer. So we're going to find K all the way over here, and it's right here. And we're going to write down that entire line. Now, if you notice, it says 1 base unit is equal to. Now, the base units in the metric system are gram, meters, or liters. Well, in this problem, the base unit is meters, whatever the second letter is. So I write down 1 base unit. So I write down 1 meter, all right, not grams or liters, but meters in this case, is equal to, and then it says here, 0.001 kilo dash. Well, that basically means that 1 meter is equal to 0.001 kilometers. All right. So that I got this line from here. Now that's the hardest part of doing any of these problems. Trust me. Once you got that down, you're golden. The rest is easy. Now, if you have questions on this, make sure you ask me. Come to tutorial and ask me, or ask me in class. Now, the next thing is we also need to look up centimeters the same way. Because that has a unit, a prefix in front of it, we have to look it up. Now, if it just said meters, there's nothing to look up there and we can move on. But this particular one has centi, so we need to look that up. So again, we go down by the right-hand side, look for centi. It's right here. Again, it says 1 base unit, in this case, meters, is equal to 100 centi. And then we add the base unit again. So we say 1 meter is equal to 100 centimeters. Now, once we have that, then we are done using the chart. And again, remember, if there's a metric unit without a prefix, then you don't need to look it up. And it's always equal to 1 base unit, gram, meter, or liter, being equal to a certain number of prefixed units. The second letter of the abbreviated prefixed unit tells you what the base unit is. Again, if the base unit of centimeter is going to be meter. If it was centiliter, it'd be liter. All right, centigram, it would be gram, whatever the second letter is. Now, the third step is to set up the grid. Now, the grid is the most important part about all of this. And you guys are going to set it up in a certain way. I'm going to ask you to always do it exactly the same way. Basically, the grid is a method of setting up complicated conversion problems that keeps everything neat and organized. All right. Now, to give you an idea of how to set it up, let's say you had a much simpler problem. Let's say you were trying to find out, let's say you had 3 dozen eggs. And the question is, how many eggs was that? Now, you know that 1 dozen eggs is going to be equal to 12 eggs. You know that conversion factor, all right? But when it comes time to setting it up, you have a choice. If you set it up where you have 3 dozen eggs, you could set it up as either where you multiply and have 12 eggs for every 1 dozen, or you could have 3 dozen eggs and you could multiply it where you have 1 dozen over 12 eggs. Both of those, theoretically, we could do from this equality. Because remember, whenever you set these up, an equality is a conversion factor. The top unit has to be equivalent to the bottom unit. 12 eggs is equivalent to 1 dozen eggs. Just like 1 dozen is equivalent to 12 eggs. The question is, which one do we do? Now, you know, just because you're familiar with eggs and dozens, that the answer is, of course, going to be, all right, 3 times 12, and you know the answer is going to be 36. But how do you know if you're not familiar with it? And the answer comes in, you analyze the units. When you want to set up these problems so that all of the units cancel out except for the unit that you're looking for. If we do it this way, the top way, dozen eggs on top will cancel out with dozen eggs on the bottom, and you're left over with just the unit of eggs, which is exactly where you want to end up. On the bottom, though, you notice how the eggs, the dozen doesn't cancel out. So here we would have dozen times a dozen be like a dozen squared over eggs, and that doesn't make sense. So we know this can't be the right way of setting it up. This way, where the units cancel out, is the correct way of setting it up. So back to our original problem. When you set up a grid, all right, when you set up a grid, you're going to use a horizontal line to represent division and vertical lines to represent multiplication. You always start with your starting point in the top left-hand cell of the grid. So we have 13.4 kilometers, and that's always going to go in the top left-hand cell of the grid. All right. Now, we're going to use our equalities. Oh, by the way, an exception is if the unit is a compound unit, such as grams per liter, then the grams would go with the number on the top left-hand cell, while the liters would go in the bottom left-hand cell with a number 1 in front of it. We're not going to be doing that quite yet, so don't worry about it. Now, you're going to insert the equality down here that has the same unit as your starting point. The matching unit must be on the bottom so that the unit cancels out. Very, very important. So if we have kilometers here, we want to have the same unit down here. So we're going to look amongst our equalities for kilometers. It's right here. So I'm going to write the number 0.001 kilometers on the bottom, and what it's equal to, 1 meter, goes on top. All right, whatever the unit that it's equal to goes on top. Once you use an equality, cross it out. Don't use it again. All right, put the equalities in the grid so that all the units but those at the end point cancel out. We have 2 more equalities. When you're done, you're going to have 1 vertical line per equality. So we have 2 more equalities, so we need at least another vertical line. Now we have meters on top. We want to make sure we have meters on the bottom. Can't use that one, so I'm going to have to use that one. So I'm going to go 1 meter on the bottom, and I'm going to put what it's equal to, is 100 centimeters, goes on top. I've now used that one. And then finally, this one's going to require another cell, and I'm going to have 100, and since I have centimeters on top, I want the same units down here. The only other centimeters is right here, so that's 2.54 centimeters, sorry, and it's equal to 1 inch goes on top. Now, double check to make sure that you have everything set up correctly. So you have kilometers canceling out with kilometers, meters cancels out with meters, centimeters with centimeters, and the only unit left, inches, matches that of our starting point. That's how we know we have set it up. So you want to make sure that everything is good. Now, you're going to use your calculators to find the answer. Here's the key thing. You're going to start at the left, and you're going to go from cell to cell. Now, when you're using a calculator, it's a little bit different than what you've learned if you had to do this by hand. If you did it by hand, you might be tempted to multiply out the top, have a number, multiply out the bottom, have a number, and then divide. Don't do it that way. That's ridiculous when you have a calculator. It's so much easier just to follow this process. If the number's on top, you multiply. If the number's on the bottom, you divide. All right? And the answers must be written with the correct units and the correct number of significant figures. Remember, however many the starting point has, that's how many significant figures your answer should have. And the answers should be written in scientific notation where appropriate. Answers between 1,000 and over, or answers of 0.001 and less, need to be in scientific notation. And make sure you circle your answers. So when it comes time to doing your math, if you don't have your own calculator, I've included a link to a really good free, very important free, online scientific calculator. All right? It's basically at eeweb.com, tools, online scientific calculator. I want you to please use this one. The key thing is it has an EE button right down here. All right? So it has a scientific notation button. Whenever you have to enter something in scientific notation, it's very, very simple with this. Let's say you wanted to enter in 4.3 times 10 to the negative 7. You just simply go 4.3, and instead of times 10 to, you just push the EE button. It's going to show up as that. It means times 10 to the, and then you go negative with the negative sign, and then 7. That number's now in there. And then you can multiply or divide as you see fit. Now, using this calculator to do our work here, remember, if the number's on top, you multiply. If the number's on the bottom, you divide. So you just simply go, in this case, 13.4. All right. Now the first number is on the bottom. You ignore the ones. So the first number is on the bottom. So we're going to go divided by 0.00. Come on. There we go. 0.001. Next cell over, notice that it's on top. If it's on top, you multiply. So you just go times 100. And then over here, it's on the bottom again. So you go divided by 2.54. And then you push equals. Now the number is this big old giant number, right? So we have to do a couple things. One, we need to make sure that it has the correct number of significant figures. And two, we need to make sure that it is in scientific notation because it's a big number over 1,000. All right. So you look at how many significant figures there are in the question. 13.4. Well, that's 3 significant figures. So we want to round off our answer after the third digit. So we have 527. All right. Now remember that 5 here changes the 7 here into an 8 because you want to round off. Also, we want to put it in scientific notation. The decimal, when you put something in scientific notation, always goes after the first non-zero digit. So, in this case, the 5. So when we rewrite it, it's going to look like this. It's going to be 5.28. And since the decimal moves 1, 2, 3, 4, 5 places, we go times 10 to the 5th. On the calculator, it might say E5, but remember, you're not a calculator. You are a human being, and you will write it like this, times 10 to the 5th. If this was a really small number, like 0.00005 or something, then it would be negative 5. So you have the number, and you have the units. Units, again, were inches. And if you're doing it by hand, you make sure that you have that, okay? Now, if you're entering this into someplace and you can't use superscripts or subscripts, remember, you could always write it like this. All right. If you're doing it on a computer, you can go 5.28 E5. Sorry. All right. E5 inches, or you can go 5.28 times, x 10 caret 5, and then inches. Okay? Either of those will be considered correct. Remember, if you have any questions, please come to tutorial. I also have another sample problem video that goes through several more of these examples. Good luck.